Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to continue a series of videos on probability theory, and then today we are going to tackle conditional expectation. And then we are saying that let our x and y be two-dimensional random variable and g of x a function of what? X. So all that g of x represents here is just a function of x. So anything in the form of x, we are just representing that by what? G of x. The conditional expectation of g of x given y, right, in probability sense, that's conditional probability sense, we learn that this one can be written as a function of what? G of what? X given what? Y. That is in probability sense. But when it comes here, it said conditional what? Expectation. So what we are going to do here is just to change this f, as you can see here, to what? Conditional. That's expectation of what? G of what? X given y. So that is what we have here. That's conditional expectation of what? X giving what? Y. So that's the reason why I said the conditional expectation of g of x giving y can be denoted by this one. So this is what it can be denoted by, okay? And it's defined by, right? It's defined by. So if we are just assuming if our x and y are what? Discrete, right? Then this one will be equal to, we are going to sum on what? X. Why are we summing on x? Because we are having y and then x value. We are summing on x because our x will vary, and then you could see here that our y is equal to a particular y, a particular small y here. So it means that our y is always going to be fixed, where our x is surely going to vary. That's the reason we are only summing on what? Y. Sorry, we are only summing on what? X. And then on that note, we are going to multiply our g of x, that is a function of x, by the conditional probability of x giving y, right, to find what? Our conditional what? Expectation. Okay, yes, I hope this one is clear, right? Yes. And then for if our x and y are jointly continuous, okay, for that one the only thing that changes from the discrete case is what? The integration sign. Okay, so we are going to integrate from negative infinity to what? Positive infinity of what? G of x. G of x times the conditional what? Expectation of x giving what? Y, with respect to what? Dx. Okay, so that is how the conditional expectation is being what? Explained. Okay, yes. So let's get ourselves some questions to solve to better our understanding. Okay, so here we are saying that the conditional random variable x comma y has the joint PDF, and then the joint PDF here will be what? E raised to the power negative x. Our x is greater than y, where our y2 is greater than 0, where our 0,2 is greater than some number. So it's going to move up to what? Infinity. Yes, it's going to move up to what? Infinity. And then the question says that find the expectation of x given y. So expectation of x, we just learned that expectation of what? X given y is equal to small y. Sorry, I'm coming. Is equal to, right, integral moving from y to what? Positive infinity, x times f of x giving y. Okay, yes. So we just learned that we are just going to multiply the function. So here, this our x, as you can see here, is represents what? The g of x, as we discussed above. So in place of this g of x, we are just going to replace what? Our x, because we said that the g of x is a function of what? X. And this is our x as we have here. So it will be x times the conditional probability of what? X giving what? Y. Okay, so if we want to further express this one, we are going to get integral moving from y to what? Positive infinity. The reason why we are using y to what? Positive infinity is that when we come to this limit, right, we are integrating it on x, right, on x, because our y is constant and our x is varying. And then when we come here, we said that our x is greater than y, which is also greater than 0. It means that we are starting from y and then we are going to end at what? Positive what? Infinity. Right, we are ending at what? Positive what? Infinity. That's the reason why we move from y and then we ended at what? Positive what? Infinity. Okay, so when we further express this, we are going to get s times we are going to expand this conditional probability to what? Joint probability distribution of x and y divided by the marginal of what? Y. Okay, so before we can solve this particular question, we have to get our marginal of what? Y, and then we divide it by the joint probability distribution, multiply it by x, integrate it with respect to what? X, and then the work is done. And I have the solution on the slides. Let's dive into the solution so that we can finish faster. Okay, so when we come here, we are saying that for the marginal of y, right? For marginal of y, when we integrate it, okay, we are going to integrate it on y to what? Positive what? Infinity of what? Our joint probability distribution, where we are having e raised to the power negative what? X with respect to what? X. Okay, and our result is what? E raised to the power negative y. You see, always for marginal of y, we integrate on what? X. Okay, that's the reason why we are moving from y to what? Positive infinity. And I told you how we got the limit to be y to what? Positive infinity. When we integrate this one, this is very easy, right? You are going to get e raised to the power negative x. And if you want to integrate this one, I just differentiate the top one and divide it by the whole joint. Okay, we are getting e raised to the power negative s all divided by negative 1. And we are going to move from y to what? Positive what? Infinity. And we are getting our result to be negative e raised to the power negative infinity plus e raised to the power negative y. And we know that this one will go to 0, and our final answer will be e raised to the power negative y. Of it, that is what we have on the slides to be this one. And then once we have been able to get our marginal of y, for us to get the conditional probability, it's just the joint divided by the marginal. And the joint was e raised to the power negative s, the marginal of e raised to the power negative y. And then if you move this one to the top here, you're going to get e raised to the power negative s plus y, right? E raised to the power negative s plus y. This is what you get. And we just move negative 1 out. You are going to get negative s minus y. Okay, this is what we are going to get at the section here. This is what you are going to get at the section here. Okay, yes. And then the expectation, the conditional expectation of x giving y, right? The conditional expectation of x giving y will be equal to, you see, I'm going to just multiply, as I already explained, we are going to multiply the x, as you can see here, by the conditional probability. Of it, the conditional probability 2 was given as e raised to the power negative x minus y. Okay, of which we will get x times e raised to the power negative y, raised to the power negative bracket open x minus y dx. Okay, yes. And then once we have this one, you see, we can just remove the negative y out. Sorry, we can just remove the e raised to the power y out, because once we have e raised to the power y inside, it's a constant, because we are integrating it with respect to what? X. So it's surely what? A constant. Okay, so we can just move it out, right? So here we just multiply through by negative 1, and then we are going to get e raised to the power negative x plus e raised to the power y, and then we can just move e raised to the power y out, and then integrate the function, moving from integrate the function s times e raised to the power negative s with respect to what? The x, right? And if you do the integration, this one, you are going to get y plus e raised to the power y bracket open e raised to the power negative y, right? And then once you multiply the two, we are going to get e raised to the power y minus y, and y minus y2 is 0, so it will be e raised to the power 0, and our final answer will be what? 1. As you can see here, the whole of this one will be 1. That's the reason why we are having our final answer to be 1. Sorry, y plus what? 1, where our y is greater than what? 0. So that is what? The conditional expectation of s giving y. Okay, yes, that is that for that. And then we have some theorem. We said let x comma y be two dimensional random variable. If g of x is a real value function of x, then expectation of what? The real value function, that's g of x, is equal to the expectation of g of x giving y, right? So if, let's say, let me break it down for you. If, let's say, expectation of g of x giving y, right, is being given to us as we calculated for some similar result here, right? And then we get, maybe we get a result for it. Okay, yes, if this one is given to us and we get a result for it, right, we just find expectation of that result. Okay, so in this sense, we are going to get expectation of x giving y to be what? Y plus 1. Okay, so if you want to calculate for that expectation again, so it will be expectation of expectation. So all that you are going to do here is also to what? Calculate what for expectation of this one. If you calculate for expectation of this one, you are going to get expectation of y plus expectation of 1. Of you are going to get expectation of y plus 1. Okay, so you see it's very simple, right? So you see I'll solve some question for you to understand what I've written here. Okay, yes. So we have, since we have conditional expectation, we will also have conditional what? Variance too. Okay, yes. So conditional variance, we are saying that the conditional variance of y given x is defined as, you know that normal univariate cases, we said that variance of what? X is equal to what? Expectation of what? X squared minus expectation of what? X all squared. So when we come here, it's the same thing. You are going to do it in terms of the condition. So expectation of x squared given for this one, we are saying that variance of y given x. So in this case, you are going to, instead of the x, you are going to, here is supposed to be y. So expectation of y squared given what? X minus expectation of y given x is equal to small x all what? Squared, right? All squared. So that is how is done for the conditional variance too. Okay, that is done for the conditional. That's expectation of y squared given x minus expectation of y given x is equal to y all squared. Okay, when you do it that way, you are going to also get a conditional variance for these random variables that we are talking about. So let's solve questions to understand all that I've been explaining so far. They say that the continuous random variable x, y has the PDF, right? So this is our PDF, right? And then we have been asked to find the expectation of the expectation of y, conditional expectation of y given x, and then we should also find the expectation of y, and then find the variance of y given to find the conditional variance of y given what? X. So this is what the question that is being given to us to solve. So we are going to dive into it. So first, what we have to do for this particular question, first we have to work for this one. Okay, you have to work for conditional expectation of y given x is equal to x, right? Small x. And then once we get the result for that, then we take the expectation of what? The result. Okay, so here we know that for us to be able to find the conditional expectation of y given x, it's supposed to be equal to integral, right? As we all know, right? As we all know, right? Yes. So we are going to get our integral moving from what? 0 to x, right? We are going to take it from 0 to what? X. 0 to x. Yes. And then since our x is fixed here, and our y is varying, we are going to integrate on what? The limit of what? Y. That's the reason why you're having 0 and then what? X. Because our y lie between what? 0 and then what? X. Right? Yes, 0 and x. Our y lie between that. So here we are going to multiply our function by y, right? Times, that's the joint. Sorry, that is not the joint, but rather the conditional expectation of y given x, right? And then that one will give us the joint divided by what? Marginal of what? X. So first, if you want to solve it, you have to get our marginal for x. Okay, so when you come here, we are also going to find our marginal of x. If you want our marginal of x, you have to integrate. We have to integrate on what? Dy. Okay, to get our marginal of x, and we will integrate on dy on the limit 0 to x of the joint e raised to the power negative s dy. And then when we do the integration very well, we are going to get x e raised to the power negative x. Okay, yes. And then we have to also get our marginal of y. Our marginal of y. And for marginal of y, we are going to integrate on what? X. And then for that one, we have already done it in our previous question, right? And then we had e raised to the power negative y. Okay, so for us to get the conditional the conditional probability of y given x, okay, for that one, that is the joint. So for the joint 2, we are going to get f of x comma y divided by marginal of x, where f of x comma y is what? Negative x, and then the marginal of x2 was given as this one, x e raised to the power negative x. That is the reason why we had this expression here. And this one is equal to 1 over what? X. Okay, this one is equal to 1 over x. That's our answer. So if you want to get the expectation of y given x, right, expectation of y given x, we are just going to multiply. So for this one will give us integral moving from 0 to what, x of what, y times what, f of y given what, sorry, the conditional probability of y given x, and this one will give us 0 to x y times what we have here, 1 over what, x. And then that's the reason why when we multiply it to that, we are going to get integral moving from 0 to x y divided by x. That's the reason why we had this one here. So if we integrate this one, right, if you integrate the whole of this one with respect to the x, sorry, the y, we are going to get our final answer to be I'm sorry, there is a mistake here, right? We are going to get 1 over 2, right, 1 over 2 times what, x, right, 1 over 2 times x. It's not 1 over 2x, okay, where our x will be greater than what, 0. So here right now you have been able to get the expectation. Coming a minute, okay, we are going to get, right now I've been able to get the conditional expectation of x given y. So conditional expectation of y given x is giving us 1 over 2x. So here we have been able to get this one. So we are going to find the expectation of what, the conditional probability of what, y given what, x, right? We are going to take the expectation of what, the expectation of the conditional probability of y given x, of which we are going to get expectation of 1 over 2x. And if we have this one, this is a univariate case, of which this one is giving us 1 over 2 expectation of what, x. So we are going to calculate for what, the expectation of what, x. And for us to get the expectation of x, we have to get the marginal of what, x. And already we had our marginal of x to be what, x times e raised to the power negative x. Okay, yes. So for us to get the marginal, sorry, for us to get expectation of x, that one too is very simple. And if you do that one, that is what I have done here. Okay, so here we are just going to move our half out. Okay, so we are going to get 1 over 2 integral moving from 0 to what, infinity. We are moving from what, 0 to infinity. The reason why we are moving from 0 to infinity is that we want to get our expectation to be in a form of what, a real number, and then based on our limit we are going to also move from what, 0 up to what, infinity, in order to get what, a real number. Okay, yes. So in terms of that, we are also going to multiply x to what, the marginal of x. So here the marginal of x was what, x e raised to the power negative x. So for expectation we are going to multiply x to it. That's the reason why we had s squared here, right? So here we are going to get s squared e raised to the power negative x dx, which will be equal to 1 over 2 integral moving from 0 to infinity of what. So you see this one represents what, a gamma function, right? This one represents what, a gamma function. And then for us to express it very well for a gamma function, right, here we have to get x raised to the power 3 minus 1, and then e raised to the power negative s ds. And if you are using 3 minus 1 here, if you multiply 1 from 3, sorry, if you subtract 1 from 2, you are going to still get what, 2, right? So we haven't added anything to it. We want to just represent it on a gamma distribution, so that we can just get our, we can just get our expectation for us in a simple way. And then if you write it in this form, right, this form represents what, gamma of what, 3, right? We are going to get gamma of what, 3 here. Once you get gamma of 3 too is equal to what, 2 factorial. Okay, so you are going to get half, right? You are going to get 1 over half times gamma of 3, which is equal to 1 over 2 times 2 factorial, which is equal to 1, right? So that is what our answer to that particular what, question. Okay, yes. So that is for the I. What about the II? So the II says we should find the expectation of y. And for expectation of y, it will be y times what, marginal of y. And then for our marginal of y too, we had it. Our marginal of y was what, e raised to the power negative y. So here it will be y times e raised to the power negative y dy. And then if you do it very well, our answer or our result will be giving us 1. Okay, yes, if you do the expectation very well, we are going to get our result to be 1. And then Our last result question was what? We should find the variance of the conditional variance of y given x. Okay, yes. So for that one too, is we are just going to follow the same trend, but we know that for conditional variance, we are going to get expectation of what? Y squared given what? X minus expectation of y given x all squared. So that is what we have here. Okay, yes. So for this one, already we have expectation of y given x. Already we have it. So you have to calculate for expectation of, we have to calculate for expectation of y squared given what? X. Okay, and for that one we are going to integrate, right? Our x is constant here, so our y is going to vary, so you have to integrate on the limit of y, and then we are just going to multiply the joints, the conditional that's the conditional probability by y squared, since here was y squared. So here, to be integral from 0 to x, y squared times 1 over what? X, okay, dy, and then this will be our integration. We are going to get 1 over 3 y raised to the power cube, right, times 1 over x on the limit of 0 to 1, and our final answer is going to give us 1 over 3 s squared, right? 1 over 3 s squared. So once we have this one, already we have this one, and then we have expectation of y given x, which is equal to 1 over 2 from the previous slide, right? Yes, from the previous slide, or yes, that's from the previous slide. This is where we got the result. Yes, 1 over 2x. Okay, yes. So that is the result for this. So for us to get the variance, you are going to get 1 over 3 s squared minus 1 over 4 s squared. The reason why, you see here was 1 over 2x. Here is supposed to what? All as squared. That's the reason why we get 1 over 4 s squared. And our final answer to be 1 over 12 times s squared, right? So in all of this one, we have been able to calculate for the conditional expectation. And most of the question we have solved here is on what? Continuous cases. So let's solve one question on what? Discrete cases too. Okay, so here we have been given a discrete case question. It said the following table gives the joint probability mass function of x and y, where we have our x to be for the rows and the y to be for what? The column. And we have been asked to calculate for the conditional probability of what? X given y is equal to 4. Okay, yes. So for us to get the expectation, first you have to calculate for what? The conditional probability of what? X given y is equal to 4. And it will give us 3 possibilities. Okay, here our y is fixed, and then our y is equal to 4. Okay, so here if we want to get our y is equal to 4, we are going to add everything we have here. So 1 over 8 plus 0 plus 1 over 8 to get 1 over 4. Okay, so the only thing that will worry here is what? Our x. And you see that our x has 3 values, that's 0, 1, 2. So it means that our x is surely going to what? Vary from 0, you move to 1, and then move to what? 2. Okay, so let's get into business. So here first you have to get the conditional probabilities. Okay, so conditional probability for x is equal to 0, given that y is equal to 4, will be given as what? The joints where our x is equal to 0, comma y is equal to 4, and divided by the probability that our y is equal to 4. And we know that from the slide we learned that probability that y is equal to 4 is equal to what? 1 over 4. We are going to add everything here to get 1 over 4. So x is equal to 0, y is equal to 4, give us 1 over 8, right? That's the reason why you get here 1 over 8 divided by 1 over 4, and our final answer here will be what? 1 over 2. So what if our x is equal to 1 and y is equal to 4? We are going to get probability that our x is equal to 1, comma y is equal to 4, right? And then when we come to the slides, when we come here, x is equal to 1, y is equal to 4, we are getting 0. So everything will run to what? 0. Okay, and then our x is equal to 2, y is equal to 4, we are getting probability that our x is equal to 2, comma y is equal to 4, divided by probability that our y is equal to 4. And then when we come here, we are getting probability that our x is equal to 2 and y is equal to 4 to what? 1 over 8. Okay, 1 over 8. That is 1 over 8 divided by 1 over 4, where we are getting 1 over 8 times 4 over 1, of which our result here will be what? Half. So once you have been able to get that one, then we are just going to group it on in a table where our x equal to 0, s equal to 1, and then s equal to 2. We had 1 over half, we have 0, and then 1 over half respectively. So now that we are going to calculate for what? The expectation. So if you want to get the expectation, you just multiply what? The x values by what? The conditional probabilities to get what? The conditional expectation. So here you're going to get 0 times half, right, plus 1 times 0 plus 2 times half, right, of which when you multiply 2 you are going to get 0, 0, and then 1, and then our final answer for that question is what? 1. Okay, and then they can ask us to also calculate for the variance of that. So for the variance, you know that it will be expectation of s squared given y is equal to 4 minus expectation of s given y is equal to 4 all squared. Okay, so only thing we need to calculate here is what? Expectation of s squared given y is equal to 4. Okay, and for that one too, we are not going to do any extra work. The only thing you are going to do here is to just square the what? The s values. So you are going to get 0 squared times half plus 1 squared times 0 plus 2 squared times what? Half. Okay, and you are going to get 2. So for the variance, you are going to get 2 minus 1. Of it, that one, the answer to is also what? 1. So that is what the explanation I can give you on what? The conditional expectation and what? Conditional variance. This is Statistics and Mathematics YouTube channel. If you haven't watched the video, please kindly subscribe. If you haven't subscribed, kindly subscribe, like, and share so that this video will get to your friends for them to also benefit. Thank you. Bye. Have a great day.